right, number 6 is a Maclaurin series problem. Kind of a challenging one, but what's important to know here is that we're asked to find a series for f, and rather than starting from scratch, which you could do would be a tremendous amount of work, you're actually expected to use the given information and realize that this series, which is the series for log of 1 plus x, is not a whole lot different than f, which is just kind of a version of that one. So I'm going to start off by writing out the series given. So the natural log of 1 plus x series is given by the following. And it gives us 4 terms, and then what's called the general term. Okay. This f series that we're looking for is a little bit different, and instead of an x in the spot, you have an x over 3. So I'm going to do an intermediate step and find what would the series look like if I plugged in x over 3 instead of x. Well, all you do for the series is you take every single x and you plug in x over 3 instead. X over 3 here squared is going to be x squared over 3 squared. I'm going to put this 3 squared on the bottom. This one's going to be x cubed over 3 squared. 3 to the third, excuse me. And then I'm multiplying that by 3. I could simplify, but I'm just going to leave it like this to kind of keep the pattern. This is going to be x to the 4th over 3 to the 4th times 3. And my general term is going to be x to the n over 3 to the n times n. So again, all I'm doing is plugging in x over 3 for every x in the first series. And then the f series that I'm looking for is x times the series that I just finished writing. And so if the function's only different by multiplying by x, then the series is only going to be different by multiplying by x. So I'm going to write this over again, but I'm going to multiply every term by x. So basically I'm going to have increasing the numerator by 1 power of x. All right, my general term, still alternating, my x power is going to be x to the n plus 1 this time, and my bottom is going to be that. All right, this is our series. We're going to use this in a couple more problems, so I'll leave that on the page. But that's your answer to part A. All right, part B said we'll take that series that we just figured out and figure out the interval of convergence. We should be thinking ratio test, so I'm going to take the limit as n goes to infinity of, I'm going to do a big old absolute value. I want to take the n plus 1th term. So this is the nth term, and the n plus 1th term would be negative 1 to the n plus 2 times x to the n plus 2 over 3 to the n plus 1 times n plus 1. All right, I'm going to make a little more room here. Okay, then I want to divide by the nth term. I'm going to multiply by the reciprocal, so that's going to look like 3 to the n times n over negative 1 to the n plus 1, x to the n plus 1. And I want to evaluate this. A couple things to notice. Since they have absolute value there, I can kind of ignore the alternating negative 1. That doesn't matter. I also have 3 to the n over 3 to the n plus 1, which is just going to be a 3 in the bottom. X to the n plus 2 over n plus 1. X to the n plus 1 is just going to be x. And I have an n over n plus 1. And so when I take the limit here, this limit goes to 1, and my answer ends up being x plus 3. For the ratio test, I want to figure out the values for which this is less than 1. And so x over 3 is less than 1 when x over 3 is between negative 1 and 1, and that's going to be when x is between negative 3 and 3. And our last step in an interval of conversion problem is to figure out should 3 and negative 3 be included or not included in my final answer. So we have to go back to our series now and think about what would this look like if I plugged in 3. So if I had an infinite series where this was my nth term and x was equal to 3, here's what it would look like. Okay, Thinking about simplifying this, 3 to the n plus 1 over 3 to the n is just 3. So I just get 3. And so this series is negative 1 to the n plus 1 times 3 over n. The 3 can be factored out, and so really you should recognize this as an alternating series, but it's 1 over n, so that's a p series with p equals 1. It's also the harmonic series, but the fact that it's alternating is key, and it's going to be, convergent because of that, which means that when I have, this was for x equals 3, that's going to be included in my interval of convergence. Right? If I do x equals negative 3, right, I'm going to have another infinite series. I'm going to have negative 1 to the n plus 1. This time I'm going to have negative 3 to the n plus 1. And then on the bottom, 3 to the n times n. Here, these two have the same power, so they can be put together. So this is actually the same as positive 3 to the n plus 1 over 3 to the n times n. These again cancel, leaving you with 3. This is 3 over n plus, from n equals 1 to infinity. That's the harmonic series, or 3 times the harmonic series, which we know to be divergent. In one case I have a alternating harmonic series which converges, in the other case I have a harmonic series which diverges. Negative 3 is not included, and so my final answer should be this. All right, for part C, I'm gonna use the same series that I figured out in part A. The 4th degree polynomial for the function f is simply going to be everything in the series up until the 4th term. And so that would be what that looks like. And if I want to evaluate that at 2, I'm going to get 4/3 minus 8 over, this is going to be 18. And then this is going to be 16 over, and that's 81. If I simplify, 4/3 minus, let's see, that's going to be 4/9. And this is going to be 16/81. I can figure out the answer to that with a common denominator of 81. This is going to be 108 over 81 minus 36 over 81 plus 16 over 81. And I think that ends up being 88, let's see, 72, yeah, 88 over 81. We may not even need to find that, but that is what the value of P of 2 is. The error, remember that the error in an alternating series is simply the next term. So I'm going to go ahead and write this next term to help me figure out the error. And that next term would be this right here. When I plug in 2, 32 over 3 to the 4th. Oh, you know what? This is a 4. I made a mistake there. 3 to the 4th times 4. I can simplify that to be 8 over 3 to the 4th. And so my error, when I talk about that estimate, that's my P4 of 2, minus my actual value f of 2. The error there has to be less than this amount, which is 8 over 3 to the 4th. That equals 8 over 81.